Okay, so this is just a work solutions to this task that was on Thursday, the 9th of July. Yes, so it was dependent tree diagrams. This is going a little bit weird. Alright, we're back to normal. So, question 1. These first two weren't particularly dependent tree diagrams in the case where you had to adjust the second line in the in your tree diagram. But the same rules still apply on the actual tree diagram stuff. These would be more independent tree diagrams. So we know our branches must add to 1, so this bottom one is 0.2 and this is 0.3. This is Tom again, even though it's on the bottom. It's just Tom after Ben fails. So we're going to put the same probabilities there. So we've done that. Work out the probabilities that both will pass their driving test. Well, both passing their driving test is here. So both passing the driving test is 0.8 times by 0.7. That is going to be equal to 0.56. Or a 56% chance of them both passing. Work out the probability that only one of them will pass. So that's going to be Ben passing and Tom failing. I'll put a little line up there to say that's the one we want. Or either Ben failing and Tom passing. So these are the two paths I want. So let's go for the pass fail. That's going to be 0.8 times 0.3, which is 0.24. Then we've also got the fail by Ben and the pass by Tom. So that's going to be 0.2 times by 0.7, which is 0.14. Then at this stage we need to add, so it's going to be 0.38. So that's question 1 done. Question 2, which I can't fit the last bit on, but we'll deal with that. Probably if I zoom in one touch. Yeah, good enough. So, funfair game. Sounds like a lot of hoopla to me. If there's any SpongeBob fans, you'll know that. And one goes to the darts. Probability that he wins hoopla is this, so the probability on the bottom is going to be 0.7. This is going to be 0.6, and same on that bottom line. So we've done this. Work out the probability that he wins at both games. So that is going to be this path. So 0.3 times 0.4, that equals to 0.12. And then work out the probability that he wins at just one of the games. So it's basically the same question as last time. At just one, that's going to be win-lose or lose-win. 0.3 times 0.6 for the win-lose. That's 0.18. And for the lose-win, that is going to be 0.7 times 0.4, which is 0.28. Adding that together, 0.46 as our answer. Okay, question 3, let me get across to it. Question 3 is here, but I'm not going to have the number on. This is where it becomes more like what this lesson was aimed at. The bag contains 3 red sweets and 5 green sweets, so the probability of red right now is 3 out of 8 because 8 sweets in total and 3 of them are red. And the probability of green is going to be 5 out of 8. Tim takes a sweet at random and eats it. So that's how we know it's a dependent question, because that sweet does not go back into the bag. So let's draw the tree diagram. We're going to have sweet 1, and then we're going to have sweet 2. So we're going to have red, green, red, green, red, green. Probability of red right now, 3 out of 8, and green is 5 out of 8. We actually only care about this path, 2 red sweets, so I'm not going to fill in the rest of it. I'm just going to fill in my probability here. Save myself a bit of working. So right now we've got 3 out of 8 red sweets. If I eat a red sweet, there would now be 2 red sweets, and there would be 7 sweets overall. So the probability of red would be 3 out of 8 times by 2 out of 7, and that makes it 6 out of 56. If you wanted to simplify that, which you don't need to do, we can just divide them by 2. Either of them is a completely fine answer. Okay, so question 4. I think there was 6 questions on this overall. A bag contains 10 counters, 6 of them are white. So the probability of white, 6 out of 10. Don't simplify that. It'll mess up your following branches. And the rest of them are not white, so the probability of not white, remember that little dash means not white, W dash, it's going to be 4 out of 10. So if they don't tell us another question, then cut another colour, and we don't particularly care what that colour is, so we're just going to choose not white. Not replaced. That means it's dependent, so there are kind of the 2 obvious key signs, eaten or not replaced. So let's have a look at counter 1, counter 2. So we're going to have white and not white, white, not white, white, not white. Right now we've got 6 out of 10 and 4 out of 10. Have a look at the path that we want. Calculate the probability that only one of the 2 counters. So that's going to be this path, white, not white, or this path, not white, then white. That just has 1 white counter there. This one would have 2, this one would have none. So we don't want these paths. So if I took a white counter out of this bag, it wouldn't affect the amount of counters that aren't white. There would still be 4 counters that aren't white, but it would affect the total amount of counters in there. And we can fill that in to make it up to 1. And if I take a counter that isn't white out, well, the amount of white counters in there is still going to be 6, but the total will change. And then we fill that in to make it equal 1. So this is going to be 6 over 10 times by 4 over 9, which gets me 24 over 90. And then I'm going to do 4 over 10 times by 6 over 9. Again, that's going to get me 24 over 90. I want to add these 2 now. So that's going to get me 48 over 90. If your heart so desires to simplify that, it's going to be 8 over 15 as the probability of him getting only 1 white counter once he picks 2 out. Okay, final 2 questions. This was a kind of a 3 strand one. Makes it a little bit harder. So right now the probability of a biscuit is 12 over 20. Do not simplify. The probability of a chocolate biscuit, I'm going to put plain. Probability of plain, probability of chocolate, and probability of currant. Oh, they've labelled this up horrible. I'll put CH for chocolate and I'll put C for currant. They could have at least called that raisin. 5 out of 20 and then 3 out of 20. I'll put arrows to them. Takes 2 biscuits from the tin. Work out the probability that the 2 biscuits were not the same type. So let's set up our initial tree. We're going to have plain, we're going to have chocolate, and we're going to have currant, and put in our probabilities. So we could have 3 branches off here. What I'm going to do for this second branch is, I only care if they're the same type or not. So I'm going to split this into 2, and I'm going to say plain or not plain. And then I'm going to split this into two. I'm going to have chocolate or not chocolate. And then I'm going to have currant or not currant. The reason I've done that, one, it makes it neater. And two, well, we only care if they don't pick the same type. I don't care if they pick plain and then chocolate or plain and then currant. That's just going to be another calculation for me to do. And I can combine the chocolate and currants into one, which is just not plain. Hopefully you followed me along on that logic. So if I take a plain biscuit, there'd now be 11 plain biscuits, and there would now be 19 overall. We can see that we want 8 over 19 to make that up, and that is basically the 5 chocolate biscuits plus the 3 currant biscuits. So we can see this is kind of working out how we'd expect it. Following along with this, we'd have 4 out of 19, because I've eaten a chocolate, and I would have the 3 currant ones and the 12 plain ones still intact, so 15 out of 19, and you can see that makes up to be 1. If I had a currant one, then I'd have 2 in there out of 19, and I would have the 5 chocolate biscuits and the 12 plain biscuits still, making it 17. So I want this path, and this path, because it goes plain, not plain, chocolate, not chocolate, currant, not currant. That means they're not the same type. If I did it with all 3s, I would have ended up having to do 6 calculations and add them together, which would have been difficult. Or you could have done all the same types and then taken it away from 1. That's another method you could have done, which some of you might have done actually, but I like this way. So let's do this. 12 over 20 times by 8 over 19. I'm going to calculate them all in a bit. 5 over 20 times by 15 over 19, and then 3 over 20 times by 17 over 19. So first let's get my denominator. They'll all be the same. It's all 20 times 19. That's 380. Okay, let's start from the bottom. 3 times 17 is 51. 5 times 15, 75. 12 times 8 is 96. Then I want to add these 3 together. Which gets me 222 out of 380. And if you want to simplify that, we are going to get 111 out of 190. It's a bit more of a difficult question just because more work to do, but nothing too bad. Okay, and Kia has 10 coins in a bag. 3 of them are £1 coins, so the probability of a £1 coin would be 3 out of 10, and probability of 50p would be 7 out of 10. Kia takes at random 3 coins from the bag. Work out the probability that she takes exactly £2.50. So think of the paths we can do for this. We could do £1, £1, 50p. We could take £1, then a 50p, then a pound. Or we could take 50p, then a pound, then a pound. They're the ways to make £2.50. Everything else is not going to do it. So by acknowledging that early, we can draw a simpler version of our tree diagram. So didn't need to draw 3 there, just need to draw 2. So we've got £1 and we've got 50p. So that's going to be 3/10, this is going to be 7/10. Again, £1, 50p, so 3/10. Oh, sorry. We take a pound, we're not putting it back in the bag, we can't use the coin twice. We have unlimited money. So if we took a £1 coin, this would now be 2 out of 9, and this would be 7 out of 9. And if I took a 50p, there'd still be 3 in there, so 3 out of 9. And this would be 6 out of 9. Let's have a look at our paths and see which ones we actually want to carry on with. So if we take 50p then 50p, well, that path is nonsense. We can never make up £2.50 from that, so I'm not going to fill that in. And if we take 50p then a pound, well, this 50p path isn't going to help us. That would make us up to £2. We'd need to just have this £1 path. So right now it's 3/9. If I take a pound coin out of that, it would be 2 out of 8. This path would work, but not with the £1. That would give us £3, just the 50p. So right now at this stage, I've taken a pound out, I've taken another pound out. I've not touched the 50p's. There's still 7 50p's in there. And there'd be 8 coins overall. Made a bit of a hash of this. I'm going to have to squeeze this in. I'm going to do really long branches like that. £1, 50p. If I was doing this kind of for myself, I'd draw much less branches, or I'd be tempted to not draw them at all, but you get that from practice. And I'd be using a much bigger space rather than this little space. I use a full piece of paper for this to draw it out nice and big. £1, 50p, 50p makes up £2. £1, 50p, and another pound. That works. So I'll take the paths I want. So I take out a pound. I must have £2 left in there. Then I take out a 50p. That doesn't affect the amount of pounds I've got. So I still have £2 and then 8 coins overall in there. So looking at my 3 paths, I'm going to label them 1, 2, 3. Path 1, I've got 3 out of 10 times by 2 out of 9 times by 7 out of 8. Path 2, I've got 3 out of 10 times by 7 out of 9 times by 2 out of 8. And path 3 goes down, up, up. I've got 7 out of 10 times by 3 out of 9 times by 2 out of 8. So these fractions are all out of 720. 9 times 10 times, or 10 times 9 times 8. This top one's 42. Oops, 3 times 7 times 2. That's 42. And the bottom one, in fact, is 42. Just the same numbers in different orders, isn't it? So now I want to add these together. So 42 add 42 add 42 gives me 126 out of 720. And if you wish to simplify that, it simplifies quite nicely actually to 7 out of 40. It's a bit of a messier question. I'd definitely use a bit more space if I had more space. And I probably could have used the paper below me, but I wanted to keep the question in screen. But there we go, that's it. So I will not print that, I'll save that. And that'll be uploaded for you as well. But that's it from me. Thanks if you watched any of this.